Okay, good afternoon. Assalamualaikum warahmatullahi wabarakatuh. We are going to start our class as usual. Please turn on your camera. And then I noticed that 1 hour ago that Aulia is very eager to come to my class. Is it true, Aulia?
Yes, sir.
Okay. As usual, please turn on your camera. We are going to start first our quiz. Okay. Aulia, can you check the emas?
Shall I share screen?
Yeah, please. So I'm sorry that I just finished the seminar 1, yeah, for the final year student that are doing their undergraduate thesis. Okay, so while you are doing the quiz, I will go pray for a moment and then we will start our class. Can you start, Aulia? Oh, still close.
Yes, still close.
Right, let me check first. Okay, and this is the last quiz, okay, the 5th quiz. And then next week we will not have quiz, and then we will start and with the midterm exam. Okay, and then after the midterm exam, after UTS, the lecturer will be exchanged. Okay, because I am the laziest lecturer, you will find ample difference between the lecturer before UTS and after UTS. The one that will teach you is Pak Irvanu, and he's very good in teaching, in pedagogy, different from me. So okay, you will see why I said every time my class that I said that I am the laziest lecturer. Okay, please, Aulia, refresh the right. Okay, you can start from now.
Yep.
Okay, I see that you already finished the quiz. Thank you very much. I'm not too concerned about your grade in this course. I think your quiz results are very good. If I am not saying enough, I think it's very good, right? So I'm sure that you can also have a good result. You will also have good result in the midterm exam, right? Today we are going to talk about work measurement. Okay, I just uploaded the material. You can check in a math website. Okay. Okay, this is the material not from me, but I maybe just modify it very little. Okay, this is from my senior lecturer, Pak Boy, who just pensioned already, finished his term as lecturer. Okay, methods, standard, and work design. So there are methods of work, and then standard of work and work design. So today we will just introduce you to this this topic, and you will have a whole blown course for this topic. Okay. So most of the time, I will just show you the illustration. Okay. Right. Okay, this is industrial engineering, ergonomics. Okay, ergonomics, sometimes we call it human factors. Okay, human factors are used in USA usually, while in Europe they use ergonomics. This term can be used interchangeably. Yeah, right. And then we differentiate between microergonomics and micro. Which one is the how to pronounce it? Microergonomics and macroergonomics. Microergonomics is because this we have micro, small, okay. So it concerns with the analysis, design, and evaluation of work center, the one that is in the shop floor. Okay, doing the, for example, assembling, doing the manufacturing process. While this is macro, okay, macro, the same analysis, design, and evaluation of work system, or I can say that organization. Analysis, design, and evaluation of organization. You will also take a course which is industrial psychology. It is more or less is macro ergonomics. Right. So this is example of an ergonomic work center. Okay, you can see that this is the worker, and then they have we need to optimize the movement of the workers. Okay, you can see that it has tray in the left and the right. Okay, the one that is the part is in the left can be reached by the left hand, and then the one in the right can be reached by the right hand. And also we have tools. Okay, just near the head. Okay, and then we have the, for example, the work order, the form over here. Okay, and we have an ergonomic chair, for example. This is an example of ergonomic work center. So maybe someone asked why we need to put the material close to the worker, because of efficiency, right? If the left hand can reach the material, and the person do not need to travel one or two steps, then it will be better for the efficiency. You will save, for example, half a second. Okay, half a second, for example. But because we have a high production volume, for example, 1,000 part per day or per month, then we can save half second by 1,000. Then we can save 500 seconds, and it can increase our productivity. Okay, this is also an example. You can see this is the table, and then sometimes if you go to factory, the worker are standing. Okay, and I think you will learn more in the course. Too long sitting like me, like this, in a comfortable chair. Actually, when I bought this chair for WFH, for working from home, I was get comments, many comments. It is not the proper chair for working. Yeah, I know. This is not the proper chair. You can see my chair. This is sofa actually, not a not office chair. Okay, but because of what, Aulia? Because of what? Then I choose this chair. What do you think?
Yes, you are the laziest lecturer in Universitas Indonesia.
Very good. Very nice. Because of I'm lazy and I like to do rebahan. Do you know rebahan, Renat? Kaum rebahan?
Yeah, yes, sir.
Yeah. What is in English? Rebahan. I think I standing or doing no. I remember that I read it somewhere when the people of China, from China, they refuse to do the work, and then we translate it as rebahan. Okay, so do not follow your lazy lecturer. Okay, follow the correct path. Follow the one that will teach you in the half part of the course, the one that will teach you after UTS. Okay, productivity importance. Okay, and then methods, standard, and work design. Okay, the example over here is example of work center. Okay, you will as an industrial engineer, you need to have the main principle how to design a work center. Okay, beside work center, we can the work itself need to be designed, work design, and then the methods of the work, we will show you the methods of work, an example, and the standard. Okay, standard of the work. Right. Okay. Okay, I don't think I need to explain this. Okay, this is not too clear, I think, right? I need to put my head is like this to be able to read this part. This is the minimum work content of product, and then we can have some defects or in terms of lean manufacturing ways, but because of defect in design or specification, and then inefficient work design. Okay, and methods, for example, the same working condition, the work center, if we have not good work center like this, then we have inefficiency. Okay, because of that. Sometimes we have an efficiency or waste because of poor planning, poor material inventory control. This will be, you will learn more on PPIC course, production planning and inventory control. Okay, and then shortcoming of workers. You will learn on industrial psychology. So if we can reduce this waste or unproductive time, then we can increase the productivity, right? Without sacrificing the work itself. Okay. Right, work design, productivity improvement. Okay, we design and develop work center where product will be produced. Okay, work center, the one that I showed the picture, the example. Continually study work center to find a better way. Okay, this is the step. I think I do not need to explain in detail to you. Okay, and this is too small for my senior eyes. Do you agree that I am already senior? I'm in my what I call it, senja, waktu senja, umur senja. What is umur senja? Age senja is my down age. It's already down age for me. Fadila Nurul Iza, do you agree with me? It's already my down. Is it true? Waktu senja, umur senja, can we translate into down age?
I don't think so, sir. But I think you're not really umur senja enough.
Oh, really? Thank you for your compliment.
Okay.
Thank you very much. Okay. So I cannot read it well, actually. This is too small for me. Okay, work design. We design the work, okay? Fit the task and workstation to the operator. And then sometimes we have problem. This is some problem, but I will not discuss this first. Maybe I will give you an illustration of work design. Okay, this is an example of work design. We want to do neck rib attachment. So we attach neck rib. What is neck rib? I'm not sure. Also, I think. And then you can see the workplace layout over here. So we have operator, we have machine, bodies pick up, yeah, over here, dispose bar, rib pick up. Okay, so we have the layout of the work center, right? And then we want to improve this work design. So sometimes we have existing method, and then we will have improved method or future method. Okay, so this is the operation, the location, the operator. Okay, and then this chart is very detailed because it explain what need to be done by our left hand. Okay, this is the part is for our left hand, and then this one is the one that need to be done by our right hand. Okay, so work design will be very detailed because I mentioned I forgot to mention that I need to mention again and again that our industrial engineering is the one that is very greedy. So a little bit improvement we need to find and to try little improvement that we can. So you can see that this is very greedy. We order the worker to do the left hand and also the right hand. Both of the hand need to work. Okay. Gak mau rugi. What is the English? Gak mau rugi. Do we have English term for gak mau rugi? So, okay, this is example of work design. So we have the workplace layout, and then also the one that need to be done. And also actually we have several things over here. This is I think operation, movement, and then inventory. Okay, so and then usually we will have detail, for example, how many seconds or how many minutes that will be needed for performing this task. Okay, this is an example of work design. So I hope that you can have an illustration what is work design. Right, so I go back to the slide before work design. Okay, which one? Okay, we want to fit the task and workstation to the operator. And then sometimes if we have repetitive tasks, okay, repetitive task, doing this for one worker for 1,000 times per shift per day, it will sometimes leads to musculoskeletal disorders. Okay, if you have maybe how to explain this, yeah, pain or pegelino or something else in the long term. Okay, in the long term for the workers. And one approach to deal with this is by performing work rotation. Okay, for example, one operator doing this for this month, and then for the next month we rotate other task than this. So maybe this is will be put stress on both hands. For example, we rotate the worker to another task that is not too giving more stress on the hands, for example. Okay, right. Any question regarding this example, the work design and also the layout of work center? Maybe you have any questions?
I want to ask. The shape in the left hand description, what does it mean? Yang lingkaran and then the rectangle and then the arrow.
Yeah, okay. So I will try to make it larger. Okay. So the one is over here is the circle is usually operations. Okay. This this arrow usually means of transportation or movement. You can see that pick up the bodies. We pick up, so we move the material. Okay, maybe we also have this. Okay, pick up the next trip. Okay, and then dispose, for example. So from this example, we usually can differentiate between the edit, the process that that give us added value, and the one that do not provide added value. The one that will increase the value is the one in circle. Okay, because we align the body, the position, and we assemble, for example. If this is not adding any value, actually just moving, the value is still staying. Okay, this is one why we need to differentiate between this column. I forgot with what is this mean for this. This is for inventory, or I think, yeah, for inventory, the up downward rectangle for inventory, or delay, yeah, for delay hold. Okay, but I forgot this one. What is this? You can try to check to Google, for example, this two-handed process chart or process chart. You can try to find, and then you will get the explanation on these symbols. Okay, any other question?
I'd like to ask, sir.
Yeah, Alicia.
So in factories, I think as we all know, there's specialization where like a group of workers do the same thing all over and they're doing a repetitive task and they're getting better at it. So do they actually rotate their work, or like they switch their task?
Yeah. Usually not. Usually not. Okay. The one that I said before is the one that has give a high stress on the body. If we have a high stress for the body, then we need to do rotation. Yeah. So in our lab, actually, we have a software, a system that can analyze a task whether it will induce high stress or not. So it's not my specialty actually. So if you interested in that area, you can go to ergonomic center, and we have the software to analyze. For example, if for example the weight of bodies is quite high, then maybe it will induce stress for the hand. Okay, but usually if your question was whether we do the rotation or not, usually no. Okay, usually no. Why? Because of the productivity. Okay, but I think I also need to add another explanation, another note. Okay, sometimes we do rotation, and then sometimes worker is assigned to do a task that is not that is not on their specialties. Sometimes we need to do that. Okay, for example, why is that? Because of the fluctuation of demand. For example, worker A is specialized in doing product A, for example. But the demand for product A is low, then we can assign the worker A to produce product B. That is one example, and it is actually the one that been done by manufacturer. So work rotation usually done by manufacturer, by factory, because of the fluctuation of demand, not because of the ergonomics. Yeah, it should be on ergonomics actually. Okay, that's my explanation, Alicia.
Okay, thank you, sir.
Yeah, is there any other question? Okay, so this is an example of work design. We design the work, the description and the sequence, the time, okay, and also the layout, okay, the movement of our body. So it's very detailed and very greedy. Do you agree with me, Hilza? We are the greediest person, maybe as industrial engineer. No?
Yeah.
What do you?
Sir, can I ask?
Yes, Azarin.
What are the lines for? Why do you need to connect the dots and like the description table? Why do you need the dots? I mean, why do you need to connect all the dots? What's the line for?
Yeah, the lines will show you very fast if we have too much change. For example, if we do like this, if we straight in the operations, this is operation, we can say that okay, that's very good. But if we have this situation, we go like this, this, it indicates inefficient. If we go this, zigzag, for example, it will indicate an inefficiency, Azarin. Yeah, it indicates. Maybe we need to rearrange. Okay, we need to rearrange the process bar here, so we do not do zigzag too much. And I'm sure if we do rearrange and we do not have zigzag, then the standard time, the total time needed will be decreased, and we will have a higher productivity. Okay, Azarin?
Okay, thank you, sir.
Okay, actually I'm being sotoy. Yeah, I'm being sotoy.
Okay, sir.
Okay, right. But that's okay. The specialty of industrial engineer is being greedy and being sotoy. Okay, so you need to be sotoy whenever you have already graduated from IE, then you go to work as in the factory or as consultant. You need to be sotoy actually. Then you can sell yourself. Right, and then we have work design. We have standard. Okay. And result of time study. So we study the work process. For example, how many times to pick up the bodies, how many times to reverse the bodies is time study. And then we have a standard. Okay, standard for doing pick up the bodies is 2 seconds, for example. And then we can give allowance. Okay, 2 seconds plus minus 0.2, for example. Okay, allowance. And also we'll consider allowance for fatigue, personal, and unavoidable delays. Okay, because the worker is human, right? So we need to consider this fatigue, personal, and also to go to the bathroom, for example, to do little chat with their fellow workers. So we need to give allowance. This is example of standard work. So you can see that we have a time over here. How many time we need? 31, 26, 29, and then we can combine 5 operators together. So this is an example of also work design, okay, and also standard work, because it gives you the time. Okay. Okay, any question? Okay, if there is no question, we will break for, as usual, 10 minutes, and we will continue after 10 minutes. Okay, we continue our class. Okay, as usual, please again turn on your camera, right? Okay, so there will be many tools that can be used for in work measurement. Okay, and the tools is usually will be taught in that class, work design methods and so on, and also you will learn on a course called quality system. Okay, so this is only several example or several, not exhaustively, so we list the important tool. Okay, the first one is Pareto analysis. Okay, Pareto is for prioritization. We want to prioritize items. Okay, the one that we need to, for example, study further. Okay, And we have this informal rule, 80-20 rule. 20% of items account for 80% of the problems. Okay, it can also means other things. Okay, so we can, for example, okay, let's try to read this first. 20% of items account 20% of items account for 80% of the problem. So, for example, if we have problem in let, for example, let go to school. Go to school, okay, for example, okay, and then maybe 80% of the situation is because we go to bed too late. Usually too late, for example. The other 20%, for example, because of we have a problem in family with our bucin, for example. Yeah. How many bucin do you have, Tara?
None.
None? Are you sure?
Yes.
Yeah. Although that I do not agree, but I will accept your answer. Okay, the other 20%, for example, because of we are very tired, for example, okay, because of the rain, because of other things, okay. But usually there are items that can be amounted to be the 80% of the problem. And this item is only this is one item, for example, one cause, two cause, and then three cause, okay, one factor, and then the rest is eight causes, for example. Okay, so we have two major causes that and then this is 20% because we have in total we have 10 causes. 20% causes affect the 80% of the problem. Affect the we arrive to the school is late. Okay, while the rest of 8 case is happens very rarely. Okay, so this is 80-20 rule. 20% of items, 20% of the causes account for 80% of the problem. This is one example. Okay, we can have also 80-20 rule in inventory, okay, and other things. So this will allow us to do prioritization. So we need to prioritize this 20% of items. If we solve this 20% of item, then we can eliminate most of the 80% of the problems. Okay, right. Order on common scale in decreasing frequency, creating a cumulative distribution. You are taking probability course, I think, yeah. If I'm not mistaken. So I think you will learn on cumulative distribution, density distribution, and so on and so forth. Okay, so I do not need to explain this, or maybe because of I'm lazy, or I do not understand the concept, or because of both. I am lazy and I do not understand the concept. Okay, so this rule allows the company to concentrate resources on the jobs with the most problems. So we concentrate on the 20% of item, and usually it can solve 80% of the problem. So this is the graphical explanation, maybe depiction. 20% of causes it leads to 80% of the problems. Okay, so we need to just solve this 20%, and then we can solve this 80% of the problem. Do we have Pareto chart over here? Okay, we have Pareto chart. And then while the rest, 80% of causes, only amount for 20% of problem. So it's advised to concentrate on the 20%. Do not concentrate on receh-receh. Yeah. Do you know the meaning of receh, Alesha, Aminda?
You mean like unnecessary, sir?
Unnecessary. It's actually necessary, right?
Not urgent. Is it? Okay, I don't know.
Yeah. Someone has said that 1 million money is not 1 million if we do not complete with 1,000 rupiah, for example. 1 juta itu nggak jadi 1 juta kalau nggak ada 1000-nya gitu ya. It's minor things, okay. Okay, receh. It still counts for the 20% of problem, but we need to focus our effort to the one that has large impact. Okay, we will have cumulative distribution like this. Okay, so for example, this is number of accidents, and then the cumulative distribution is into 100%. And then the accidents are caused by, I don't know, CAP, ABY, PBY is what I actually do not know. Job code, okay. This is because of job code. And we can identify two jobs, okay. And then it almost amount to 80, but maybe we can take three jobs, CUP, ABY, PBY, that will amount to 80% of the accidents. So we concentrate in those 3 jobs. This is Pareto analysis. Any question regarding Pareto analysis? Okay, easy, right? Very easy. Good.
Sir, I would like to ask.
Yes, Ashley.
So is it like the Pareto analysis that 80% of what's happening is the effect of something that comes from the 20%? Like that?
Yeah, that's true.
Oh, okay. Thank you.
Yeah. You can see from this picture, right? 20% of causes lead to 80% of the problem. Okay, this is not an exact law, okay, but it's usually happens. Okay. Okay, maybe because of the Markovian property. If you learn more about Markovian property, then maybe you can connect to exponential probability distribution, and then we may derive this 80-20 rule. Okay, I'm just being so quiet. Right, this is Pareto analysis. It's not too clear. Keterangan pergantian sistem penyimpanan pasien lama tidak bawa kartu. Okay. Right. So this is the cumulative frequency, and then percentage cumulative. This is not too, the item is not too much, I think. So we do not have 80-20 rule. actually in this example. Okay, we move to fishbone diagram, and sometimes they call as Ishikawa diagram. Okay, fishbone, fish. Okay, fish and bone, the bone of fish, the bone of fish. This is used usually for identifying the cause. We have problem and we try to identify the cause. One problem can be derived or can be caused by several factors. Okay. The problem is usually we will put at the head of the fish, and then we branch the fish because we will have fish bone. Okay, we branch the fish into factors, and then the factors usually human, machine, methods, material, environment, and administrative. This is not standard. You can change according to our needs, right? So this is one example of fishbone diagram. So we have problem of employee complaints. Okay, we have employee complaints, and then we can try to identify the branch, the main branch, based on human, machine, administrative, materials, method, environment. Okay. So in terms of human, the employee complaints is caused by moral boredom, for example, because the human is bored, then they do complain, for example. Because of age, because of my down age, umur senja, and then I tend to do complaints. I tend to do curcol, yeah. And then because of machine, for example, and then because of vibration, the machine is vibrating too much, and then it's not comfortable for the worker, then the worker will file complaints. Because of administrative, because of pay incentive, they do not give pay incentive. Because of job rotation, for example, yeah, because of my friend in my group is usually I hang out very much, and then they rotate me to another department, and too many pretty girl, for example, and it make me stress, then I complain. It doesn't make sense, yeah, the case, but it's okay. Yeah, once I work in a factory, and then the factory was producing TV and monitor. Until now, they're still producing monitors. And then when I go to the shop floor, there are too many pretty girls. So I'm not in the shop floor. I'm at the office. I was in the office, and I go to the shop floor, and it the situation give me stress because I am still lajang, single. I was single that time, and I cannot choose properly. There are too many options. Too many options is hard for me. Okay, environment, noise, lightning. Okay, so this is example of fishbone diagram. We try to enumerate or exhaust what are the cause that will make employee complaints. And then after we have this fishbone diagram, we usually try to identify what are the frequency. How many times that, for example, vibration causing employee complaints? How many times the job rotation leading to employee complaints? So we try to record the frequency. Okay. After we record the frequency, then we can perform Pareto analysis. Okay, do you get it? So we have causes, many causes, and we try to record the frequency. Okay, how many times, and then we can do Pareto analysis. What are the causes that are contributing the most for the employee complaints, for example, and then we can try to address those causes. Right. Any question? No? No question. Good. Okay, and then we have Gantt chart. I think you already know Gantt chart. Used for planning of complex projects. And then start and completion time, also duration. And then major event can be broken into smaller subtasks. Okay, this is the example, literature research. Okay, or for example, meal, completed, schedule. Okay, this is the example of Gantt chart. Okay, job work site analysis guide. We perform a walkthrough, observing the area, the worker, the environment. Okay, particularly useful in workstation redesign. Okay, this is an example of job or work site analysis guide. So maybe I can try to zoom. Yeah, I zoom in a zoom. Job work site description, inserting stem to funnel. Okay, what happened? How do part flow in out? What kinds of motion are involved? Are there any jigs, fixtures? Yeah, when we have the disaster 2 weeks ago, yeah, I think we have jigs or fixtures. It's the one that to hold the material. Okay, jigs and fixtures. Are any tools being used? Are there awkward finger? Are there any lifting? Yes, heavy glass funnel. Okay. So this is an example. Remark, look at positioning belt. Very hot. Okay, this is an example of the job analysis guide. So this can help us in doing the fishbone diagram. Okay, doing this fishbone diagram. And also, if we have fishbone diagram, then we can do the Pareto analysis and so on and so forth. And then we have operation process chart and flow process chart, flow diagram, worker and machine process chart. The one that we show to you, the two hand and also the standard time is worker and machine process chart. Okay, the two hand is worker process chart, what are being done by our hand. And machine process chart, you can see this is the interaction between the worker, the man, and also the machine. Okay, this is an example of worker and machine chart. We have flow process chart, gang process chart. We have OPC, operation process chart. We will learn more in the production process. Okay, production process. This is an example, operation process chart. Okay, similar actually, similar with the one that we have. This is operation, the circle one. I think this one is assembly, because we assemble this part and this part, this line and this line into, this is sub material. We can say this is sub material, and then we combine into to assemble. And then this the same, this triangle is for storing, for inventory. This is OPC. Do we have example of OPC? Okay, this is an example of OPC, the last slide. You can see operation process chart, and then maybe I need to do zoom. What are these doing? Manufacturing type, telephone stands. So I think this is assembling telephone. Yeah, assembling telephone. We have legs, we have seals, we have top DWG. I don't know DWG. So sew to rough, join two edges, and how many minutes. You can see this is the time. Okay, and then we can see the O12. This is the code of the process. Okay, the code. Each process can be can have a more detailed process. Okay, more detailed OPC. Oh, sorry, the rectangle is for inspection. Yeah, now I remember, the rectangle is for inspection. Check overall dimension. Okay, the rectangle is dimension, inspection, sorry. And then we combine the top DWG, this one, and seals. Okay, we assemble 4 seals to top, and then we assemble with the legs. Okay, this is why we have the lines is to be one line, because it's assembling. Okay, we have more inspection. I think we have material over here, and then inspect finish. And then we have summary, how many operation, how many inspection. Operation is the one that adding value, right? Inspection is make sure the value is right, but it is not adding a value actually. If we can, we need to eliminate this inspection because it is a waste. Okay, any question regarding work measurement, work design and measurement? It's very light, I think, introduction to work design and measurement.
Sir,
Okay.
I want to ask,
Yes, Ashley.
is the operation chart similar to this thing called the database flow chart, or is it different?
Similar with what?
Database flow chart, or is it different?
Database flow chart. I'm not sure what do you mean with database flow chart. Usually in database, we have ERD, entity relationship diagram. So it will connect the table in the database. So I'm not sure which one. Do we have a database process chart in here, Ashley, in this slide?
I'm not sure. I don't think so.
Okay, what I understand with database is place which we store our information. So maybe we can store the OPC into a database. Okay, but so it will be called database process chart, but I'm not sure actually. So I'm not being sotoy. So I'm saying I'm not sure. When I'm sotoy, I'm not saying I'm not sure. Ashley. Is it okay for you if I'm being sotoy? What do you think? Can we call Shanaya Nashwa?
Yes,
What-
sir.
Is is it okay if I'm being sotoy?
I think because you're our lecturer, you still, have more knowledge than us. So I think it's fine.
Yeah, you are being full. So, ketipu kayaknya. Okay. Yeah, okay. So, yeah, that's the math answer. Okay. So, what I want to speak. Okay. Later on, if you graduate, usually if we are sotoy, we can try to make it right. Okay. So we say to our customer or our friend that, oh, this is need to be like this, 1, 2, 3, 4. But after a while, we know that this is wrong. We can revisit again. We say to our customer, okay, I'm sorry that we have a wrong or inaccurate statement regarding the point number 2. Okay, we can always do like that. Yeah. So being sotoy is very helpful if you are industrial engineer. Good. I think that's all for today. And please study again for work measurement. We will have the final quiz before we have the final class in introduction to IE, and we will have midterm exam. See you and happy have a good weekend. Yeah, we will have weekend tomorrow. See you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you, sir.
Sir, I'm sorry.
Yes.
Yesterday quiz, is it already have the nilai or not yet?
Yesterday quiz. Ya, ada.
Okay. Okay, I'll chat you, sir.
Okay, see you.